the beginning of sorrows. The book of Daniel talks about this, right? The beginning of sorrows being when what is it? The thing that happens in the temple where it's like desolation, the abomination of desolation, right? That happens, and then it's the beginning of sorrows, like everything goes downhill from there. This is the beginning of your sorrows in math class. The idea is this, and Brooke will verify. Yes, Sierra? Do you need the lesson?
Yeah.
From the storage unit? Okay, so the beginning of sorrows is this. We are now going to be solving distance problems. And distance problems are horrible because they entail on water. Now kind of dump the hide in there. And then turn on the heater as a April Fool's joke. Alright, so we are working on distance problems. Here's the key. And I'm adding, I can already feel it. I'm adding to your formulas. Quiz! Yeah. April, no fools.
Today's April Fool's on a bowl.
Alright, so here's the idea. Sir. Thank you. Are you done? If you don't want to be here, I'm happy to send you outside. That's fine. So, the idea with distance problems is this. Distance equals rate times time. Write it down, write it on your notebook, write it on your note cards, write it wherever you need to write it so that you know and are assured that distance equals rate times time. Why? Because the distance that you travel equals I printed them. I knew. I didn't forget. They just reminded me.
Oh wait, you look.
Okay. The distance that you travel is equal to, why is your computer open?
We have a quiz for Wednesday.
Times time. Now, does this make sense? If your car is traveling 25 miles per hour and you go for 2 hours, how far did you travel?
50 miles.
50 miles, right? Because 25 times 2 is 50 miles. So we're already familiar with this concept. But here is the idea. Instead of giving you these equations in number form, which you've already seen, they are now giving them to you in word problems. You will have to use the equations, or you'll have to write the equations yourself. So the equations that we're going to end up with are as follows. Now let's just read the problem. On Tuesday, the express train made the trip in 12 hours. So I'm just going to write down the information I know. That way I can use it later. So this is the express train. On Wednesday, the freight train made the same trip in 16 hours. Those are examples of what? Distance, rate, or time? Time, right? Because they're in hours. And that's how we figure out that they're a time. Now, they want us to find the rate of each train if the rate of the freight train was 15 kilometers per hour. What is that an example of? Distance, rate, or time? Kilometers per hour. It's our rate. It's something that you would see on a speedometer, right? Miles per hour is what your car goes. It also has kilometers per hour. So any distance divided by time is a rate, okay? So this said that it was 15 kilometers per hour slower than the express train. And now we have to solve for everything. How do I do this problem? Excellent idea. We are going to write equations for each of these things. And since we've already been practicing solving equations of this sort, we will have no problem. Except for the math problem, of course. That's always a problem. So, what equation can I write with this 12 hours? So what did we say this was? A distance, rate, or time? Time. So I can do time of the express train, or TE, equals 12. Simple enough. Let's try another one. How about this 16? If we did 12 hours was TE equals 12, what would I do with the 16? Kara? TF equals 16 is correct. Now, let's try this one. If I know the freight train is 15 kilometers per hour slower, what are we talking about? Distance, rate, or time? Rate. Because distance over time is a rate. Now, just like our problems yesterday that we talked about, you want to set the two rates equal and then adjust one of them. So I'm either going to add or subtract 15 from both sides. So if I want to do RE equals RF, what should I write here? Plus 15 or minus 15? Go ahead, AJ.
Minus 15.
Minus 15. Would say that the express train is 15 miles per hour slower than the freight train. Is that what we want to say?
Yeah.
The express train that made the trip faster.
The train was
So we would do
plus 15.
plus. That's right. The express train is faster since the freight train is slower.
Wait, is the express train RE or is RF the freight?
RE is express and RF is freight.
Oh, sorry, that makes sense.
You got it. Now, can we solve this with 3 equations?
No. Okay. Yes. 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 Yes.
Well, we can solve for 3 variables if we have 3 equations. Do we have 3 variables?
Yes.
No, we have 4. 1, 2, 3, 4. So how many equations do I need? 4. So what's my last equation? What do I know about this problem? We've already done time things. We've already done rate things. What can we say about the distances of them? They are the what?
Distance.
Sierra?
Would be RETE equals RFTM.
What does that tell us about the distances, though?
I have confusion.
It says.
I mean, that's the right answer, but I want to know why. So that is correct.
Say TE, TF equals
But
RE.
why? What do I know about the 2 distances? Let's think it through. It says the express train made the trip in 12 hours and the freight train made the trip in 16 hours. What do we know about the distances? What do you think, Evan? Are they the same or different?
No, they're the same.
Are you sure?
Do you agree, Riley?
Yes.
Do you agree, Kara? You don't? Do you agree? Make it, you can't go like a circle. What do you think? Are they the same or are they different?
Yes.
So, what piece of information tells us that they're different distances?
One has
Don't raise your hand.
One is 15.
Don't raise your hand. Nothing, right? Nothing tells us they're different. It says they made the trip in 12 hours and 16 hours. It's the same trip. So the distance is the same. So what do I do if the distance is the same?
Wait a minute. Are you sure that's? Oh.
Yeah, because they don't give us any other information anyways. So it has to be the same.
One's longer than the other.
One spent more time, but it doesn't mean that they spent more distance, right? One of the trains is going slower. So of course it's going to take more time, but one of the trains is going really fast. So it's going to take less time. But they're going to the same place. They made the trip. So their distances are the same. So my final equation could be that the distance of the express train equals the distance of the freight train.
What if it
But-
says
Is that adding more letters?
Yes.
Yeah, now I have 6. But I know that distance equals what?
rate times current rate?
So instead of writing DE, I'm going to write RE, just like Sierra said, TE.
Whoa.
Because the rate times time is the,
Distance.
everybody.
Distance.
And for the other one, rate of the freight train times time of the freight train is the distance of that one. Have we solved this problem before?
No.
Yeah, absolutely. You've had 4 equations and 4 variables.
Yes.
You take the most complicated one, you plug in everything, and you see what you get. You've done this already so many times. It's been in every problem set up to this point, right? Yesterday's problem set, it was number 12.